All right, section A, question 1. Define the term capacitance. We're not looking for a formula here, so it's not enough to just write down the formulas, the symbols. That's not going to get you a point. You have to write it in words. So, definition of capacitance, the one we're looking for is this one, the ratio of charge per unit potential difference. Okay, that's the definition that we want. Okay, part B. A student set up a simple circuit to charge a capacitor. This is the symbol for capacitor here. Okay. Given that an uncharged capacitor with a capacitance of 200 millifarads, okay, that's milli, and that's to the order 10 to the minus 3. It's connected in series with a 400 kiloohm, okay, that means multiply by 10 to the positive 3, and a battery of 3 volts. Calculate the maximum current which flows. Okay, so the equation that we need is this one right here. This is Ohm's law. You might recognize it as voltage is equal to current multiplied by resistance. We transpose it for current to make that the subject of the equation. And then we're going to substitute in our values that were given for the voltage or potential difference and the resistance. Before we plug in our resistance, we're going to convert that to ohms. Okay, so we're going to multiply that by 10 to the power of 3, which is just add 3 zeros. So that's 400,000 ohms. So it's 3 divided by 4, 0, 0, 0, 0, 0. When we plug that in our calculator, we're going to get a really small number. But no worries, we know how to fix that up. So you're going to get this 0.0000075. Okay, so we're going to change that to engineering notation. You might recognize this from doing scientific notation, and it's very similar. All I'm doing, I'm moving my decimal point to the very end, because I see when I do that, I'm going to get nice multiples of 3. When I say engineering notation, I'm talking about the value, the order of magnitude for the prefixes milli, micro, kilo. They're all multiples of 3s. Okay, so if I put this in scientific notation, then I'll get 7.5 times 10 to the minus 5. But I don't have a nice prefix for that, so I can write that neatly. So I'm going to go 1 over, and I'm going to write it as 75. So the whole number 75 times 10 to the negative 6, and I recognize that as micro. Okay, so 1 step lower than milli, micro, and so my answer is going to be 75 micro amperes from current unit. Okay, so I'm all good there. Now, the next part of the question asks us to calculate the maximum charge that flows through the circuit. Okay, so when you hear charge, you might think, oh, hey, I'm going to use the equation for charge. That has to do with current, but nope, that one is not going to be the one, because we don't have information about the time. So this one is not the one that we're looking for. We're actually going to use the formula for capacitance. Okay, so capacitance is equal to charge over voltage. We're going to rearrange that to make charge the subject. So we take the voltage over to the other side. It's multiplied now. So charge is equal to capacitance multiplied by voltage. Okay, if we go back up to the first part of the question, we will see that we were given the capacitance and it was 200 millifarads. Farads is the unit of capacitance. Milli tells us that we're going to multiply the value by 10 to the negative 3. Okay, and we can write that a little simpler. We don't have to use the base and the exponent. We can just simply divide by 1000 and then we'll get 0.2. Okay, so to go from millifarads to just farads, you're going to divide by 1000. Just like you would go from millimeters to meters, you divide by 1000. So that's what you do before you plug that in your equation. So charge is equal to 0.2 farads multiplied by 3 volts. 3 volts comes from the question, previous part of the question. So we multiply 0.2 multiplied by 3 gives us 0.6, and the unit for charge is the coulomb, which is represented by capital letter C. Okay, so notice this is 3 points. So we get a point for rearranging and converting. We get a point for our substitution and our simplification. Okay. Okay, and the final part of the question asks us to state 3 factors that affect the capacitance of a capacitor. Okay, so 3 things that we can do to the circuit that will either increase or decrease the capacitance of the capacitor or affect how much charge it can store. The first factor is going to be the surface area of the plates of the capacitor. Okay, the larger the surface area, the greater the capacitance. The smaller the surface area, the smaller the capacitance. The second factor is the dielectric material, the nature of the material between the plates. Sometimes that can be an insulator like glass, or it can just be air. Okay, so depending on how good the dielectric is, there will be more or less charge leaking from the plates. So that will also affect how much charge it's able to store. And then the third factor is the distance between the plates. Okay, we already know from the study of electrostatic forces that the closer two unlike charges are from each other, then the greater the attractive or repulsive force between them. So the distance between the plates also affects how much charge can be stored. The further apart they are, the less attraction the plates are going to have, and that will affect how long the charges stay on those plates. So those 3 factors: surface area, dielectric material, and the distance between the plates. Those 3 can affect the surface, can affect the capacitance of a capacitor. So